This is a rock climbing thought experiment. 3 kids go climbing at their local cliff. There's one guy here climbing that weighs 100 pounds. His friend on belay, or holding him on belay, weighs 120. And they have another friend up here at the top, looking down over the cliff, watching. They have an anchor rope set up that's tied to a boulder with a setup as shown. For this climber to get up the cliff, he has to climb up a series of holds, or rock holds, or ledges to get up there, but then he falls and stops right here below the ledge. So the only way he can get down is to be lowered down the cliff. There's nothing for him to hold on to be able to climb back up. When he falls, it creates a sudden yank on this rope that pulls this boulder loose from the mud, and that boulder starts to slide across the bedrock toward the edge of the cliff. All 3 of them recognize what's going on. The friend here at the top pushes up against that boulder and holds it to keep it from falling over the cliff, but he can only hold it for a few seconds. So during that time, the friend here holding the rope on belay brings the rope over to the climber so the climber can hold on to that rope. So now there's no tension on the rope from the guy that was holding it on belay. Let's also say, for the clean, easy math, that this is a frictionless, inertial-free pulley system. So we don't have to calculate friction. And let's say this boulder needs 150 pounds of force pulling on it to pull it to the edge of the cliff and pull it over the edge of the cliff. So if there's less than 150 pounds pulling on this rope, then the boulder won't slide over and everybody lives. The question is, did this improve this kid's chance of survival by holding onto the rope? You can pause the video here if you want to think about it. I'll give the answer in 3, 2, 1. And this is what it looks like. With the kid here hanging at 100 pounds, he has to have another 100 pounds of force pulling down to keep him up. So that's 100 pounds pulling down here, and here there's 200 pounds hanging from the pulley. Once that kid grabs his own rope right there, and so half of his weight is on this end and the other half is on that end, then it looks like this, with 100 pounds, with 50 pounds on that end of the rope and 50 pounds on that end, for a total of only 100 pounds, which is less than the 150 pounds needed to pull the boulder over the edge of the cliff.